So I have started recording this class now. So first thing we'll do is we'll check the preparation or practice we have done with the tables. Okay. So let's see who remembers what. So I'll start with let's say Ayush. Yeah. So Ayush, last class we planned to memorize tables till 6. Remember? Ayush, you're on mute.
Yes.
Yeah. So we plan to memorize table till 6. Correct?
Yeah.
Okay. Let me see how much we remember and what we have to practice more. Okay. Okay. All right. So Ayush, I'll ask questions. You can keep answering them quickly, one after another. So six foja.
24, 40.
Okay. Six foja.
What?
Six foja.
24.
Okay. Five ninja.
9, 45,
Okay. Four eight.
48, 32,
Very nice. Six ninja.
6 nines,
Mm-hmm.
54,
Okay. Six
6 6,
36. Okay. So so I can tell you, Ayush, that you have certainly studied. You have certainly practiced, okay? That I can see. And that's a good job, okay? So this one is for you. Okay. Now, uh what I don't want to go to table 7 and 8 right now. What I want you to do is before the next Saturday, now you again keep spending 5 minutes every day, and by next Saturday we will get it better. Meaning till table of 6. Right now we are taking a second or more to think 6 8 48. That 1 second also I want to remove. Meaning as soon as I say 6 8 you should say 48. 4 9 36. 6 6 36. Likewise, okay. I want that speed because that will make your math very very quick. Okay. Good job, Ayush. So that is the
okay.
target for you, okay? Apart from the this week, I did not give homework. I was thinking that no, you'll be able to focus more on that, and you did. But I want it to get better, okay?
Alright.
So next Saturday, I want you to be solid with all your tables till 6, okay? Let's go to
Alright.
Ishan, then I'll come to Abhi. So Ishan, I know we planned to finish table till 12, right? In the last class. In fact, for you it should
Yeah.
be 9 or 10, but since you knew the table, so let's quickly check, okay? 12 6 there.
Um, 72.
Okay. 9 8 there.
72.
Okay. 6 9 there.
54.
Okay. 6 7 there.
6 7, 42.
Okay. 8 8 there.
64.
Okay. 6 8 there.
40, 48.
Okay. 9 9 there.
81.
Okay. 11 7 there.
11 sevens,
Uh-huh.
77.
Okay. So good job, Ishan. I don't have any concern. But that even that 1 second that we take, right? I want that also to become super quick. Okay. So let's keep practicing that, keep spending that 5 minutes every day for memorizing tables because that's the formula for being champion in maths. Okay. All right. Now let's
Okay.
go to Abhik. So Abhik, I know we are meeting after some time, and I'm not really sure if you're doing well and being able to spend some time with studies. But tell me honestly, if I ask you the tables, what are the tables that you think you remember or you know very well? And it's okay. I
So
mean,
I know all the tables
you know.
except for I forgot like 12.
Okay, I'll not go to
I
12.
know I know 1 to 11. 1 to 11.
Okay, I let's see 10 and 11. I don't really worry because those are easy ones. So let's see up to table of 9. Let's see how much is your speed. Okay, and how much
Okay.
is your accuracy. And again,
Okay.
if you make mistakes, if you forget something, it's okay to make mistakes. That's what I keep telling all my kids. Okay, so let's see. 7 7 ja.
49. Yeah.
Very nice. 49. Okay. 8 4 ja.
32.
Okay. 6 8 ja.
48.
Very nice. Okay. 9 9 ja.
81.
Very nice. 6 4 ja.
24.
Very nice. So, 8 8 ja.
64.
Okay. 7 2 ja.
14.
Very nice. So Abhik, I see that you have memorized tables. You are very good with tables. Okay. So this is going to be a strength when you do maths. Okay. And I see Ishan is doing very good with tables. No.
I learned the
Uh-huh.
I learned the four angles.
Okay, I'll come to that. I'll come to that one by one. So we have an agenda for the class. I was just checking the basic things, right? If you know the tables, you'll be able to do the maths faster. I see Shan is doing good. Ayush has memorized tables. You are you are good with tables. We'll check for 2 minutes with Gitesh, and then we'll start with what is our plan for the class. Okay. So the goal for you, Abhik, would be that if you see till the table of 9, I did not find any problems. 10 and 11, I did not check purposefully because those are easy ones. So I'll leave it up to you, Abhik. It's not, there's no rush. You memorize table till 9. Just spend 5 minutes every day. Just sing it like a song. And if you think that there's nothing that you forget, you can go to your parents, say, okay, fine. Ask me some questions. Check if I know everything. Okay. And if you find something that you're getting stuck with, memorize that table. Okay. I'm not giving you any new target for now. You keep challenging your parents, saying, okay, ask me some questions and let's see if you're getting stuck anywhere. Okay. Our plan is that we should not get stuck and we should be perfect with with the tables. Okay. Let's go to Gitesh now. So anybody else who is not talking probably can go on mute so that way we can we can continue. Okay, Gitesh, good morning.
Good morning, sir.
Okay. So, Gitesh, did you get a chance to memorize tables till 12?
Yeah,
Okay.
I did.
Let me check. Let me check quickly. Okay. I'll not ask you other tables. Let me check only 12. Okay. 12 6. Ja.
72.
Okay. 12 9. Ja.
108.
Okay. 12 3. Ja.
36.
Okay. 9 9. Ja.
81.
Okay. That was a surprise. Okay. All right. I was just trying to trick you. So good. So one thing is very evident that all the kids have spent decent time for doing tables, and you guys are getting better with that, and that is going to be a foundation now. Let's move on to the class topic for today. So I'm just doing a recap. So far, in last few classes, we were focusing more on basic shapes and geometry. Okay. So we learned about the line segment, rays. We learned about the angles, different types of angles, right? Right, right angle.
Yeah.
Uh, we learned about the acute angle, obtuse angle. We learned about the triangles, the different classification of triangles based on angles and sides, right? Where we learned about the equilateral triangle, isosceles triangle, and scalene triangle. Okay. And then when it
Yes.
comes to angles, we learned about the right angle triangle. And based on angle, there are three types of triangles again: right angle, acute angle triangle, obtuse angle triangle. Right. And then we started with the quadrilaterals, where we have four shapes, four sides and four angles. Right. So that is where we learn about rectangle, square, rhombus, kite, parallelogram, and trapezium. Yeah. Now, a quick question to
Yes.
everybody. Whatever I talked about, is there anything that anybody doesn't know, doesn't recall, has any confusion about?
No, I
Uh,
don't, sir.
yeah, okay,
No, sir.
okay, okay. Now coming to Abhik, because Abhik is joining after a break. So yeah, it's important to know what Abhik recalls, what he doesn't. Yeah, yeah,
I
Abhik.
feel like I'm behind them because I just learning geometry.
So, so I will take 10 minutes to quickly walk you through. Okay. We have just learned the basic properties of the shapes. Okay. I will explain that to you. I'll just explain that to everybody so that no, we do a recap, and then we'll go to area and perimeter. That's what we are trying to learn. Okay. All right.
After that, you want to go to volume two?
Yeah, of course. We'll go places. All right. So let me share my screen, and let me know once you guys are able to see it.
Not yet.
You have to tell me once you're able to see the screen with your smiling faces.
Oh, I can see it now.
I
I
see.
can't see it.
Yeah. Okay.
I cannot. I can see it.
Okay. Now let me know once you're able to see the white screen.
Yes.
Yeah.
Yeah.
Wonderful. Okay. So everybody stay on mute. I will ask questions when needed, and that is when I'll want you to respond. Okay. So first thing, we started with line, line segment, and raise. Okay. The difference between the three things is line doesn't have a starting or ending point. This just depicts the direction. Okay, that means if the paper is big enough, you can make it bigger. Okay, if the surface on which you're drawing a line, it can go till the edge of the surface on which you're drawing it. So there's no fixed length. It just gives you a direction. When you look at line segment, you will not, what you will see is there's no arrow like what we saw in the case of a line. Line segment is a no piece of shape which is made by joining two points, and it has a fixed length. So it's like a straight line where which has a starting and ending point. In case of a line, there was no starting and ending point. It was going in as far as you can think of. And the third flavor was a, a ray, where I was saying that it starts from one point. Like I always show my phone, right? So when I look at the torch, this starts from here and then goes as far as it can go. So so these are called light rays, right? Same way in geometry we say it rays. So which has a one side is fixed, one point is fixed from where the no it starts, which is called the origin or the source, and the second side is infinity. It can go as far as you can think of, unless you block it. So these are three different things that we saw with a line or whatever you call it. So line with no fixed length, it just gives a direction. Line segment has a fixed length that comes by joining two points, and array, which is something that starts from a point and can go as far as you can think of. Any doubt? I will ask this question primarily
No.
for Abhik and Ayush. These are younger ones. Yeah. Ayush,
Yeah.
Abhik, no question. Ishan,
Uh, are we
No.
gonna learn about harder stuff?
Yeah, so harder, see, there's nothing called harder stuff. It's about we know it or we don't know it. So I'm just going step by step. Okay. Yeah.
Yeah.
Okay. Now, Ayush, no problem, right? We can go ahead.
Yeah.
Ishan, no issues.
Yeah.
Okay, wonderful. I'll not ask Gitesh. Okay. All right.
Okay.
So let's go to next thing that we learned. That is called angles. Okay.
Yeah.
Angle is nothing but when two line segments or line meet each other at a point, and the angle denotes the inclination, the closeness between them, or how far they are. You can see the movement of my hand, right?
Yes.
This is getting bigger. This is getting bigger.
I
This is
can.
bigger. Yeah. No. Can you see my hand?
Yeah, I can see your hand.
Yeah. So I'm saying, see the angle is nothing but the closeness between two lines when they meet each other. See here, look at both my palms as two lines, right? You can see the butterfly movement, right?
Yeah.
This is
Yeah.
smaller angle. This is getting bigger. This is getting bigger. This is getting bigger. This is bigger. Yeah.
Yeah.
Yes, I
Well,
can see.
So, so same way. So far we looked at one line segment or array. Here we are talking about two of them together. When they meet each other, the closeness or how far they are with each other, that is called angle. And there's a tool called protector that you use for measuring the angles, which looks like a semicircle. Okay.
Oh, I know that. I know that. I
Uh,
use that in
Okay,
school.
not going there then. Okay, so now we'll just talk about the angles. So this angle, and this angle. There are three types of angles that you need to know at this point in time.
Acute, right angle, and obtuse.
I don't have to
Yes.
press that. So you know it. Okay, and the
I
property
think.
the property of these angles is this is less than 90 degree. That's a small angle called acute angle. Something that is small. 90 degree if it is perpendicular to each other, like the surface and the wall in your house. If the wall is like this, tilting against your surface, that is when it will break. So it has to be right. It has to be perpendicular, 90 degree. It's called right angle. Okay. And something which is bigger than 90 degree is called obtuse. Okay. So far, no doubt. Everybody knows it.
No doubt. No doubt. Yeah, I know that from like no doubt.
Okay.
No doubt.
Let's move on. Let's move on. Now, so we looked at single line, we looked at two lines making angles, we know the properties. Now we went to the third shape, which has three sides, where we are dealing with three lines or line segments. That is called triangle. The property of the triangle is it has three sides, and here we see three angles also. That is what I was talking about. So, Abhi, based on the property of the sides or the angle, you can classify them into different triangles. Okay. When
Oh,
let's look at the sides. When all the sides are same, equal, it's called equilateral triangle. Okay. And all that we are talking right now, it gets recorded, it gets put on the YouTube channel. Okay. So you can always watch this also later on. If you forget something, you can watch this video and revise. Okay.
Okay.
Now,
Okay.
if both the sides are, if all the sides of a triangle are same, that's called equilateral triangle. Okay. Now the second flavor is, come on. If only this side and this side are same, meaning two of the sides are same and third one is not, that is called isosceles triangle. Okay. Yeah.
Okay. Yeah.
Equilateral,
yeah.
isosceles. Third is an outlier. It's called scalene triangle, meaning all the sides are of different size. This is 2 centimeter. This might be 5 centimeter. This is 7 centimeter. All are different. Nobody
Okay.
wants to know each other. Nobody is same as each other. Okay. Is scalene. So based on sides, length, there are three types of triangle that we talked about. One is called equilateral, when all the sides are same. If two sides are same, that's called isosceles triangle. And if all are different, it's called scalene. Any doubt?
No doubt.
What?
No.
No, no,
It's
not all.
primarily for Abhik because Abhik has joined late. So that's why I'm just trying to make sure that everybody gets to the same level and then we go from there. Okay. Now, based on the angle, again, triangles can be of three types. And
Yes.
again, as you know, there are three types of angles. One is called acute angle triangle. One is called one is called acute angle. One is called obtuse angle, and one you call as right angle. So if the triangle has all the angles, okay, all the angles lesser than 90 degree, meaning all the angles are acute, that is called acute angle triangle or acute triangle. Okay? Yeah, all the
Yeah.
angles are smaller
Yeah.
than 90.
Yeah.
All angles are acute. Acute angle triangle. Look at one triangle where one angle is 90 degree. Only one. Okay. If one of the angle is 90 degree, that's called right angle triangle or right triangle, whatever you call it. Okay. And the third flavor is this, where one of the angle is more than 90 degree. Okay. So this angle is called obtuse angle, right? So the triangle's
Yes.
name is obtuse angle triangle. Okay.
I see.
All right.
All right.
Yeah. So we looked at different types of triangles based on sides or angle. Now let's see. We are going step by step, right? We looked at one line, three types: line, line segment, and rays. We looked at two lines, that is, it makes angles. We looked at uh, acute angle, obtuse angle, and right angle. Then we looked at three lines. That is what makes triangle. That is where we looked at different classification of triangle based on sides or angles. Yeah. Now, after three comes four. So we look at the shape which has four sides. That is called quadrilateral. Okay. Now, any shape and every shape which has four sides is called a quadrilateral. They are different quadrilateral. They are different shapes in the quadrilateral family. Okay. One is called rectangle. Oh, see, I did not draw a good rectangle. One is called rectangle, one is called square, one is called rhombus, one is called kite, one is called parallelogram, one is called trapezium. Now let me ask Abhik, which one you know, which one you don't? I'll only focus on that one. You know
Oh, I actually know all of them.
all of them. When I say, do you know what I mean by that is, do you know the property of these shapes? When I say property, what it means is, if I look at rectangle, let me go quickly, okay? If I
Is
say
that they have
rectangle,
four sides? All of them have four sides.
everybody has four sides because this is from the quadrilateral family. So everybody is supposed to have four sides and they will have four angles. That is given. Now I'm saying the specific property of all these shapes. Okay. So if you look at rectangle, the opposite sides will be of same length. So this one will be same. This one will be same. Okay. And all the angles will be 90 degree. Every angle is 90 degree. Every angle. Okay. So that is what makes it a rectangle. So every rectangle is a quadrilateral because it has four sides. In a rectangle, the opposite sides are of same length and every angle is 90 degree. That is the property that will not change. This is what you need to know. If I'm saying this is a rectangle, what I'm saying is this side and this side are same, this side and this side are same. Okay. And every angle, the two sides that make angle, there are four angles, all four angles are 90 degree. Yeah. This is the property of a rectangle. That is what I want everybody in the class to know.
Okay.
Because every other formula you can derive. Formula is what a property is what you need to know. Okay.
Okay.
Then we go to a square. What is a square? A square is something. A square is also a quadrilateral. It has all the sides are of same length. In rectangle, we saw only the opposite sides are of same length. Here we are saying all the sides are of same length, meaning if this side is 5 centimeter, this is 5 centimeter, this is 5 centimeter, this is 5 centimeter. Okay. That's what makes a square different from a rectangle. In rectangle, you will say all the angles are 90 degree. Square also has all the angles 90 degree. In rectangle, you will say opposite sides are same length. Square also has opposite sides same length. But square is unique because it has all the sides same. Okay. So it
Okay.
is similar to rectangle, but there's one extra property that square has, which makes it different. That is all sides being same length. Okay. The third shape is a rhombus, which is nothing but a square. But if you get it by squeezing, let's say this is the square, okay? I don't know if it looks like a square, but if I squeeze this square, okay, I made it longer. This was my square before. I squeezed it. I made it longer. So the length of all the sides are the same, but the angle is not 90 degree. This became smaller than 90 and this became bigger than 90. Like you can, if this was a square, I squeezed it. See the length, my fingers are the same length, okay? Just that they came closer to each other, right?
Yeah.
So this
Yeah.
became smaller, these two angles became smaller, this became bigger, but these sides are the same. So here, the difference between a square and rhombus is that what is common is square and rhombus both have all the sides of same length. But in case of square, all the angles are 90 degree. In case of rhombus, they are not. Yeah, Abik?
I yeah.
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 Okay. So see, again, I will keep on asking just till I get the confidence that yes, the kids are able to follow me. Okay. If we take one class extra for learning something, that is still fine, but it's not fine to learn something which is not right. Okay. Now, the next shape is called kite. Kite is something that I have spoiled my life with. I used to fly kite during my childhood days. Okay. You guys have probably not seen that here. So kite is like a small toy made of paper, and it
We
has
know
no.
that.
Ah,
We know that. I know that. I
you
guess.
guys know that, yeah. So
Yeah.
it's kite is also linked with some of the festivals back in India. We fly kite during certain season or during certain festivals. But the property of the kite is that it is also quadrilateral, no question about it. But it has two pair of sides of same length. So this side and this side are same length. This side and this side are of same length. So if you try relating that with other shapes that we have seen, right? In rectangle, the opposite sides were same length. Here, this is adjacent sides are of same length. Only these two, and these two are of same length. Okay. If they are not, your kite will not fly. Okay.
Okay.
So this is the property of a kite. So we have looked at rectangle, square,
Wait. Can
rhomb.
you repeat? Can you repeat the thing you said?
Uh, so we are looking at the property of the quadrilaterals, right? So we looked at the property of rectangle.
No,
We
I
looked
was talking about the kite. Can you tell me the
okay.
property of the kite again?
The property of the kite is that the sides, the adjacent sides at the top and bottom, they are of same length. That's the only property that you need to know.
Okay.
And there's no commitment around the angle size. Okay, it
Okay.
doesn't say whether it has to be 90 degree or not. So in case of kite, the angles are not 90 degree. That I can tell you. Okay,
It
but
looks
only
like it
sorry.
looks like two are obtuse and two are acute to me.
Um, kind of. I will agree. It'll have something similar to a rhombus. These angles will be smaller. These will be bigger. So these two, this one and this one will be acute angle. These two will be obtuse. Okay. But the property definition doesn't say so. Okay. You can have kites of different shapes but they will be called kite if these two sides are of same length and these two sides are of same length. Okay.
Okay.
Next two shapes we want to know about are called parallelogram and trapezium. And I will not be able to teach you guys these two shapes unless I tell you what is meant by parallel lines. So when we were looking at the lines, we looked at single lines, we looked at pair of lines when they made angle, and then we looked at other shapes. We did not look at the parallel lines. When we say parallel lines, if you guys have ever sat on a train, the railway track on which the train runs is a very good example of parallel lines. Okay, parallel lines are a pair of lines where they are equally where they are at equal distance no matter where you check. Meaning, if this line and this line are parallel, so the distance between them here versus the distance between them here versus the distance between them here will be the same. And no matter how far you extend them, they will never meet. It is as good as a railway track, as I said. If the railway tracks come closer to each other or go far from each other, in both the case, the result is only one, a train accident. So parallel line tells you that it's a pair of lines like a railway track which will never neither come closer to each other nor will go far from each other. Okay? Because nobody wants the accident. So parallel line is a pair of line which will never meet no matter how far you extend them, and second property is the distance between them always remains fixed. Any question here?
Yes, sir.
B?
No, sir.
Okay.
No, sir.
All right. So we learned about parallel lines. Now we can look at these two shapes. This is called a trapezium, where this is also this is also a quadrilateral, but only the opposite sides, only one pair of opposite sides are parallel to each other. They are not of same length, but they're just parallel. Okay. These two lines are not parallel, right? Because if you extend them, you can clearly see that somewhere they will, and if you go down, they are getting farther from each other. Okay, which we don't want. Only the opposite, this one pair of opposite lines are parallel to each other. That is called a trapezium. A shape, a quadrilateral
Trapezoid.
or trapezoid, both. Yeah, yeah. Like we
So
they did. I'm sorry.
first question middle. Like
What is that?
you said you'll ask us questions. Like yeah.
Yeah. No, 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 I was not asking question. I was just completing this one. Then we'll go to the basic
No, like
concept.
asking questions for us.
Yeah, yeah, I
Like
will ask question. Don't worry. Last week I did not give you guys assignment because we were still catching up on the shapes, understanding the property. And now we have understood the property enough. We'll look at the area and perimeter conceptually, and then I will ask you guys questions. Okay. So today we will touch upon the concepts of area and perimeter, and tomorrow we will do some area and perimeter for square, rectangle, and right angle triangle, and then I'll give you guys some assignment so that you can enforce your learning with these concepts. But today and tomorrow we'll make sure that we go deeper into area and perimeter, and we understand that in a very strong conceptual way. Okay. All right. So trapezium, any doubt? Trapezium or trapezoid? Any doubt so far?
no.
No? Abik, you're fine?
No.
Okay. So
Yeah, I've
trapezium,
done these shapes before.
okay, that's good. So trapezium we know. Now the next or the last shape in this segment of family is called, this is not the one, is called a parallelogram. And it again relates to the concept of the parallel lines. In trapezium, we saw there's only one pair of lines which are parallel to each other. Other pair was not. In parallelogram, It's a complete thing, meaning the opposite sides are parallel to each other. So this one is parallel. This one are parallel as well. Okay. So a parallelogram is a quadrilateral where the opposite sides are parallel to each other. Meaning, if you extend the opposite sides, no matter how far, they will never ever meet. Okay, that's the parallelogram. Now, a quick sneak into what we have learned already. If you look at a rectangle, it is also a parallelogram actually, because the opposite sides are equal and all the angles are 90 degree.
Yeah, I
If
see.
yeah, they will not meet each other. Okay, so actually
Wait,
a rectangle is also a parallelogram, is what you can say. Okay,
wait a second. Isn't like wait, is it like square
coming to that,
parallelogram?
coming to that. I'll go step by step. I want you guys to hear one information, process it, then go to the next one. Now you look at the square also. Sorry, this is not a square. This is what I was telling one of my kid. I need to take drawing classes. My drawing skills are not good. So if you look at square also, opposite all the sides are same length and all the angles are 90 degree. And what that means is actually the opposite sides are also parallel. Okay. So a square is also a parallelogram. So a rectangle is a parallelogram, square is a parallelogram. If you look at a rhombus, they are also symmetric. So though the angles are not 90 degree, but they are symmetric. And what it means is this line and this line are parallel to each other, this line and this line are parallel to each other. So a rhombus is also a parallelogram. And why we are stressing on this property is primarily because there are a lot of things that you can do with geometry, and you will learn the formulas, lot of those stuff. But there are a lot of relatable concepts, and that you can use only if you are very clear about the property of each and every shape. If somebody comes to you saying a pair of parallel lines, you should know it simply means the two lines that will never ever meet each other. The distance between them will remain fixed. Okay. So now let me solve this problem by using a rectangle. Rectangle, right? What we know, this one and this one are equal. What we know, this one and this one are equal to each other. Yeah. Can you guys hear me? Yeah. Can you guys hear me?
Yeah.
Yeah. Okay.
Yeah, we can, but it's kind of glitchy.
Yeah.
Yeah.
There was a glitch. I think there's some network issue in between. Okay. So
Yeah,
now,
that happened yesterday for me.
okay. Now let's look at this rectangle. Okay. And we know the property of rectangle says the opposite sides are equal to each other, meaning this one and this one are equal, and all the angles are 90 degree. Okay. Let's not believe that they are parallel. Okay. For a minute. Okay. Now look at this line and this line. This line and this line. This one and this one are equal. This one and this one are equal. Now just look at these two lines. See here, this is the distance between the two lines. Here, this is the distance between the two lines, right? This line and this line, right? This part is the distance here, and this part is the distance here between the two lines. And the distance between the two lines are same. That's what makes it parallel, right? Similarly, if you look at the other two sides, this one and this one, okay, these two are also parallel because this is one place where we are seeing the distance between them, and this is the other place where we are seeing the distance between them, and both are same because a rectangle. So what we are seeing is the distance between the two lines opposite to each other remains fixed if I go by the property of a rectangle. That's what makes it a parallelogram, because The opposite sides are parallel. Sides are parallel because the distance between the two lines are the same at 2 points that we checked. So these are relatable concepts. Okay. No, I don't think anybody has taught me saying that rectangle is a parallelogram because of the distance. But I could relate that okay, this line and this line are parallel because if I see the distance here and see the distance here, this is same because it's a rectangle. So I can say okay, these two are actually parallel because the distance between them is not changing. So this is parallel. Now if I look at this side and this side as two lines, they are same in length. This one and this one are same in length. That means if I am checking the line at two different places, I find that the distance between them is same. Oh, that means they are parallel to each other. So that is how we derive that okay, a rectangle has opposite sides, that is a property. Opposite sides of same length, that is a property. Angles are 90 degrees, that is another property. But we also found that okay, the distance between the opposite side remains the same. That makes them parallel lines. And if the opposite sides are parallel to each other, that qualifies them to be called a parallelogram also. Isn't it? Are you guys with me?
Yeah.
Yes, we're with you. Yeah, we're with you.
Okay. You could understand what I was saying, right?
Yeah.
So,
If
so
one
summary
side.
is, yeah, summary is a rectangle, a square, a rhombus. They are also parallelogram because the property of parallelogram says that the opposite sides are parallel to each other. Okay.
Okay.
Now let's go to the next part of the class. And here I will draw some cute pictures for you guys. What do you guys see here?
Each
It's
angle has a like it's getting smaller and smaller, and uh the smallest one has a less area, the biggest one has the most area.
Hmm. So I want you guys to think like babies. Okay. That is when you learn much faster. So, Gitesh, what you said was actually very correct. And I can tell you that you are no more a baby. You have grown up. But the point I was trying to make here was that from if I just by looking at these shapes, if I don't know anything about geometry, what I can make out that for drawing these different shapes, I need different size of paper actually, right?
Yeah.
I cannot
yeah,
use
you actually do.
yeah, I cannot use this smaller paper for drawing this bigger rectangle, correct? I cannot do that. So
Yeah,
what
you
that
cannot do that because that's not what you're supposed to do.
right. So what I'm trying to infer from that is the different shapes that we see that needs different size of paper for drawing them. Okay. And that different size of paper is nothing but the area needed by that shape. Okay.
Okay.
If somebody says, find out the area of this guy, okay, trust me, there is no formula that exists today that you can use for finding the area of this guy. But if you know conceptually what an area means, you can break this into smaller pieces and then use the formula for those area. Say, okay, this part is one area, this is another area, this is another area, this is another area. I will find the area for the smaller pieces if I know the formula and then join them together. That makes my complete area. This is what you guys will learn in the eighth grade called composite area. Okay, don't worry about it right now.
Okay.
I'm just explaining you.
Yeah, I've heard of that. I've
Mhm.
heard that.
Yeah,
I've heard of it.
yeah. No, so see again, whatever we learn in maths at least, these are very relatable concepts. We just have to be very clear about what exactly it is and what is that I know and how I can relate my knowledge and understanding to solve the problem. Okay. Okay. So when somebody says, right, that math is a very difficult subject, that is when I start worrying about it. Okay. Math is not difficult. It's just that we have not done our bit. So whatever we have done so far with respect to geometry was to make sure that any shape that we come across, we should be able to visualize that and then relate to it. So now in the next class, we'll talk about the area of a rectangle, area of a triangle, area of a square, area of a circle, whatnot. Okay. Now let me.
Wait, there's a square area for a circle?
There's an area for circle also. So if you guys don't learn anything new from me, why will you join the class? Yeah. Okay. Yeah. Coming back to this one. So if somebody tells you find out the area of this guy, you will be worried. I'll be more worried because I don't know any formula for this. But if I know area is nothing but the space it takes, I can break it down to smaller pieces. Okay. Now it looks better. There's a rectangle and there's a semicircle. Now the first question I will ask myself is, do I know how to calculate the area of this guy and this guy? If I do, I'll just add them together. That's what is area. So any area, okay? Today I'm going to spend another 10 minutes to force you guys to believe what is area and what is perimeter. And then tomorrow I'll teach you guys the formula and how those formulas are derived. And then you'll become a master to calculate area and perimeter for all small shape, a small simple shapes. Okay. Yeah.
Okay.
Now, okay. By looking at this, if somebody asks me what are these, my simple response to them will be this shows how much space these will take.
You're glitching.
Okay.
You're
Can
glitching.
you, can you hear me okay now?
Yeah, we can hear you. Yeah. Okay.
Okay. Uh, all the blame should go to Spectrum because Spectrum is the one who is creating problem. Okay. I'm not stopping. Okay. All right. So coming back to the point that I was trying to make was by just looking at this shape, I can tell as a child that this is one shape which has four sides. I need certain area for drawing it. Okay, so certain space for drawing it. This is a smaller shape which is a triangle. It needs a smaller area compared to the other one that we saw. This is a circle, a much smaller circle, a baby circle, which needs even less space to draw. Okay, I don't know what shape it is, but it is a shape which is bigger than this guy and this guy,
Uh,
and maybe this guy.
I have a question.
Yeah.
Can you solve area for a semicircle?
No, so that is what we are going to learn tomorrow. Don't worry, don't rush. I will teach you guys the area of a rectangle, square, triangle, and a circle. And if you know the area of a circle, you'll divide that by two to make it a semicircle. Yeah. So right now I'm still injecting the concept. I'm enforcing the concept. If somebody says area, if somebody says area of this guy, this is the space that it takes. I need that bigger surface to keep this one. If I try putting this on this pencil, I cannot do that because the pencil doesn't have enough area to keep this guy. Okay. So area is something you is the space that you need for keeping it on a surface.
Is that a
Okay.
chess
Or drawing it on
piece?
a. I'm sorry.
Is that a chess piece?
What is that? This one? I don't
Yeah.
know. It is one of my kids' toy. It was just here with me. Okay. Now, if I look at this, let's say somebody says, "Look at this one." Okay. I need a big enough a surface for holding this. If I try putting it on the top of this remote, you know what will happen, right? So area is nothing but the space taken by that particular shape on the surface for holding it or drawing it. Remember that. Okay. That's the only thing I want you guys to carry forward. Now, you would have heard about something called perimeter.
Yes.
Perimeter is nothing but the boundary. Okay. Imagine the shape as your land, okay, that you got as a gift from your parents. Okay, this is your land, and you have to create boundary around it. The length of the boundary is nothing but the perimeter. Okay, here whatever shape it was a quadrilateral. The perimeter of that will be this plus this plus this plus this. So you start from this place, walk along the boundary, add it together, that is a perimeter. If you are looking at perimeter, oops, if you're looking at the perimeter of this guy, you'll probably start from here or here, wherever you are starting from, go along the boundary, add the length, come back to the starting point. That is your perimeter. Looking at this, you are starting from here, walking along the boundary, adding it together, that is your perimeter. Okay. If you are looking at, somebody will trick you by saying, giving you a hexagon. Hexagon because it has six sides. Okay, this one, two, three, four, five, six. Some will say find out the perimeter of the hexagon where every side is 6 centimeter. Okay, so you will every side 6 centimeter.
Six.
You'll write
36 centimeters.
right. No, I'm saying I will do that in a very simple way. See, first thing I should know is okay. Fine, every side is 6 centimeter. You're asking me perimeter. Okay, perimeter is all the sides length. I'm starting from here. 6 plus 6 plus 6 plus 6 plus 6 plus 6. 6 times
Or
6.
or you can do 6 times 6.
Yeah, 6 times.
36.
Right? So what I'm saying is you when you look at a shape up now somebody will say, okay, fine. Find out the perimeter of this guy. Yeah. Okay. Very simple. You have to look at okay, this is a shape which has one, two, three, four, five sides. Perimeter means the boundary. I have to count the length of all the five sides, and that is what is going to be my perimeter. Based on the information that you have for that question, you will use that information, add them together, that becomes your perimeter. If somebody says, find out the area of this guy, what should come to your mind? At least from me so far. So you will say, okay, fine. Area of this guy means the total space that it takes on the surface. I can break it into smaller pieces. I know what is a rectangle. I have not seen this kind of a shape, but I know what is a rectangle and a triangle. Okay. So area of this guy will be sum of the area of this and this. If by any means I can find out the area of this guy and this guy, I can just add them together. That becomes the area of the shape that I was given. Okay. So these
Okay.
are when you look at area, when you look at perimeter, you should be very clear conceptually what exactly it is referring to. If you know the concept, then it's just about knowing the formula relating to it and then doing it. Okay. That is why I want you all to remember one formula that yeah, go ahead. Go ahead, Abik. So, one formula that I keep asking everybody to remember, not only for this class or this grade or this year, for rest of your life, I call it TRAN. Okay. T stands for trusting yourself that you can solve the sum. Okay. Whenever you are given a sum, a formula, or a question, always trust that yes, I can do it. And that's only a belief that you have to keep it yourself. Second is called R, T R. R is about reading. So when you get a question, read it enough. Read that question once, twice, thrice, four times, five times, till you get bored. Till you think that you understood each and every line of that question. Somebody says, no, I'm just saying something, okay? That one tap fills a tank in 3 hours, another tap fills the tank in 4 hours. If I put on both the taps together, how many hours it will take? It might look like a complicated question, but read it once. Read, okay, one tap fills the tank in 4 hours. Okay. One tap is taking 4 hours to fill a tank. Okay, that is one part of the question. Second tap fills the tank in 6 hours. Okay. So that this guy is saying, okay, there's a tank where you have two taps. You can turn one tap on, only
I,
one tap, it'll take 4 hours.
I think
Second tap, yeah.
I think the answer will be 2 hours.
I will not even worry about that. I'm not even trying to solve that problem. What I'm trying to tell you guys is the TRAN formula that I use. Meaning, first is trusting. Okay, if you are given a question, just go brave, bold, confident that yes, I can do it. Anybody can do it. I can do it. Keep that trust with you always. R is when it comes to reading. You read the question once, twice, three times, four times, five times, till you actually get tired and bored of reading that. Okay. Then comes A, the analysis part. When you have read the question enough, you know what exactly it is asking. You at least know what it is asking. Then comes the analysis. That is when you'll try relating your knowledge with what has been asked, and you'll figure out, okay, so this is the information I have, this is the formula I know, I apply this formula, this is what I will get. Okay, that is when you're getting your brain to work, right? You're realizing, okay, this is how I'll do it. And then N, that stands for Nike, just do it. So if you trust yourself, read the question enough, analyze before you try doing it, then it's all about Nike. That is just doing it, because by now you have made your mind how you're going to do it. Then just putting it on a paper. Okay. If you don't read the question, if you don't analyze your approach, and then you try doing it, you are bound to make mistake, and that is what I don't want any of you to do. Okay. That's the key that I want you guys to keep in mind. So whatever we have learned today, we did the tables, we revised all the properties of the shapes, we looked at what is area and perimeter conceptually, and tomorrow we are going to learn some formulas, and then that is what will come as assignment for you guys for this week. Okay,
Okay.
that brings us to the end of the class. Any questions before we wrap it up?
No, sir.
Everybody's tired now. Huh?